Bismillahirrahmanirrahim. We have to study about the trigonometric identities today. Okay. Before I start this, I want to make sure that you people know that what is the difference between um, an identity and an equation. Can you see this sign over here? This is the sign of an identity. Who will tell us that what is the difference between an identity and an equation?
An identity is true for all values of x, but an equation is only true for certain values of x.
Very good, very brief and very accurate. Identity is, for example, if you have, there is 2x is same as x plus x. So this is an identity, okay? You cannot solve it. If you start solving this, you will have no result for this. But you can put any value of x on both sides of this identity, okay? And if it was something like this like 2x equal to x plus 1. So this is an equation which is only true for x equal to 1, okay? So if there is a quadratic equation, you might have two solutions for that. Cubic will give you three solutions, okay? So depending on this, on the nature of this equation, on the type of this equation, while identity is true for like for many values of x, okay? Now, um, so we have to see that like you have already practiced this. Uh, I mean, more than 50% is already done. Let me tell you how I'm saying that this is already done. If you look at this exercise, if I take you back here, look at this. When you was trying to solve the questions from the parts from the ninth question. So look at the C part. You have 3 cos, sorry, the part E, you have 3 cos square x minus 3 that is equal to sine x. So you see this question here. So you were writing the whole of this equation in terms of sine x. So you changed this cos square x with 1 minus sine square x, है ना? And then you have all this equation in only in terms of sine x. So that is what we mainly do in identities, where we have to show one side of the identity to the other side of the identity. Like that is they're normally known as the left hand side and the right hand sides, okay? So uh, let's start now. This question number one, you people are already familiar with this. It says express this in terms of sine x, okay? So you know that if you want to write this in terms of sine x, so there is no problem with this sine square x, but you will be changing this cos square x, because this is the identity that you will be using a lot here. Sine square x plus cos square x, that is equal to 1. And from this you have sine square x, that is equal to 1 minus cos square x. And then your cos square x is 1 minus sine square x. And then there's one more identity that you will be using. The tan x is going to be sine x over cos x. So when you have to write all of this in terms of sine x, you will be changing this cos square x with this expression here, okay? So this will become 2 sine square x minus 7 into 1 minus sine square x plus 4. Okay, you can leave it up to this. And if you have to write this into the simplest form, so this is 2 sine square x minus 7 plus 7 sine square x plus 4. So this is finally 9 sine square x minus 3. So this given expression has been written only in terms of sine over here, okay? This initially had both sine and cos in it. Now there is only the sine in this. Now let's get started with the identities which start from the question number 2. You have to be very alert, okay? And you have to be asking, arguing, okay? Uh, just to make your things clear over here, okay? Now let's look at this. Um, let me first make some space here. Okay, so here we are. Part A, to part A, we have cos x tan x, that is same as sin x. So see, how do we prove these identities? So I'll be saying, okay, my left hand side is, the left hand side is cos x tan x. So instead of tan x, I'll be writing sin x over cos x. So they have cancelled. So this is sin x. So that is going to be equal to the right hand side. Okay. Look at this B part. Okay, I'm doing these parts. You will do the same parts again totally yourself. Okay. This is 1 minus cos square x over sine x cos x, that is same as tan x. Okay. Now, please remember this a plus b into a minus b, which is a square minus b square. Just remember that this can be used over here. Okay. This is used, in fact, a lot in these identities. So 1 minus cos square x can be written as this 1 minus cos square x. So I start from the left hand side. So can I write it as, oh, that will be of no use. I think I should be changing this with sine square x. Oh, so this 1 minus cos square x can be changed with the sine square x. Yes. So this is sine square x over sine x cos x. So one of the signs is cancelled with this. So you're left with sine x over cos x, which is going to be tan x, and that is your right hand side. Okay. That is being applied in this part E, or even in this part C. Look at this, the a square minus b square thing. It says cos square x over 1 minus sine x. We have to show that this is same as 1 plus sine x. Okay, so I'll be starting from the left hand side. Yes, cos square x. I'll first change this with 1 minus sine square x. And there is 1 minus sine x. And then using this identity over here, this a plus b into a minus b, that is a square minus b square, I should be allowed to write it as 1 plus sine x into 1 minus sine x whole over 1 minus sine x. So you see that these are cancelled. So you're left with 1 plus sine x. That is your right hand side. Okay. So I give you some time here to try these, and then I'll come back and show you how you can show how you can prove these identities. Okay, part D. We have 1 plus sine x minus sine square x over cos x. We have to show that that is going to be cos x plus tan x. Acha, sometimes if you look at this right hand side carefully and try to just manipulate this a bit, like if you write your right hand side like this gives you a clue, an idea that how to go about this. Now look at this, there is cos x over here. Okay, so I can assume that I should be getting something like this. Okay, and which can be written backward like this, and then you can write this as cos x plus tan x. Okay, so now clearly I have a clue over here that I should combine this 1 and minus sine square x. Okay. If I do that, like this is your, you must start saying that which side you're taking. You have you're totally free to start from any of the sides. You can start from the left hand side and show it same as the right hand side, or you can also start from the right hand side, showing this to be same as the left hand side. So um, I prefer to start with the side which has more terms in it. So this is normally the left hand side which has got more terms in it. Okay, now the left hand side now becomes 1 minus sine square x plus this sine x over cos x. Look, I am going to get this thing here. Now this 1 minus sine square x is cos square x plus this sine x over cos x. So remember this, if you have a plus b over c, you can write it as a over c plus b over c. So we are going to split them. So this is cos square x over cos x plus sine x over cos x. So this is cancelled. So you're left with cos x, and this is going to be your tan x, and that is the right hand side.
सर
Yes,
cos square x कहाँ से आया?
look at this 1 minus sine square x is cos square x, because we're using this identity that your sine, look at this identity I've written here, sine square x plus cos square x, that is 1. And from this you can write like sine square x is 1 minus cos square x. And if you need cos square x, that will be 1 minus sine square x.
Okay, sir, I get it. Thank you.
Okay. Okay. Now there was someone who was asking for this E part. For this E part, please apply the identity that if you have a square minus b square, you can write it as a plus b into a minus b. Try this one. Inshallah, you'll get this. Okay, very good point raised here. Please remember, please remember, you cannot switch the terms from left hand side to the right hand side in this identity. Okay, you cannot divide the, I mean, both the sides with something, or if you want to take square on both sides, you can't do that. Okay, so like in this part F, you can divide the whole of this identity by cos square x. Okay, so rather you take cos square x common from this left hand side, you will see that within a minute you will get to the solution. Look at this. If you take cos square x, so this would be cos square x left here plus sine square x. And you must be very friendly with this, familiar with this identity, that sine square x plus cos square x, that is equal to 1. So this makes it cos square x. Okay. One more thing, whenever you're applying this sine square x plus cos square x thing, please remember there has to be a square on them. Sine square x plus cos square x, that is equal to 1. There should be squares on them. They should both be positive and their angles should be same. I have seen students writing this sine x plus cos x equal to 1. No, you can't do that. Remember this sine square x plus cos square x, that equal to 1, that has been derived through the Pythagoras theorem. Okay, so therefore both of them should only be squares. They should be positive. The angles should be same. Only then they are going to be equal to 1. Okay, so please remember this. Okay, this question number 3A. There's something for the better students, the better ones. Like, I mean, when I say better student, that means the ones who have greater interest in mathematics. Okay, there are no better or the worst amongst you. So there are some, obviously there are some of you who like mathematics more than the others. For those of you who like maths, who want to practice, who love practicing maths, so you see, if you want to learn one more identity over here, please remember that whenever you have sine x plus cos x whole square. Okay. So when you apply the whole square on it, this becomes sine square x plus 2 sine x cos x plus cos square x. If you just rearrange these terms, you can get the terms like this. And again, your favorite identities um, here, that is sine square x plus cos square x, that is going to be 1 plus 2 sine x cos x. So if you have sine x plus cos x whole square, you can write it as 1 plus 2 sine x cos x. Okay? And if there is a minus between them, so for the minus, if there is a minus, there will be a minus over here. ठीक है बच्चों? Okay, now this B part here, this 3B. So I'll be starting from the left hand side and I'll take 1 plus cos x common from the whole of this expression. So I have 2 here, and then minus. Please use the brackets, okay? So this is 1 plus cos x into this 2 minus 1 is 1 minus cos x. So you have 1 minus cos square x. Okay, a plus b into a minus b is a square minus b squared. And 1 minus cos square x is sine square x. And that is your right hand side. And in the C part, you must use all this working here in the C part.
Sir,